Hi, Math 2. This is page 153 of our workbook, and it's the beginning of Unit 7, Lesson 1, and this unit is about circles. You can think of this unit having 4 parts. Lessons 1 through 4 are about theorems about a circle, dealing with the central angles, the inscribed angles, tangent lines. And then lessons 5 through 7 deal with an incenter and circumcenter of a circle. And then we have lessons, I believe it's 8 through 9, which are arc, length, and sector area. And then we have the lessons after that, beginning with 10, that are about the radii and radians in a circle, different topics. So we have these 4 different subsets of this unit. So let's begin with our lesson 1, learning some vocabulary for a circle. So in this first activity, 1.2, we're looking at some examples of what are chords and not chords. So I'll give you a moment to look at the 3 examples of a chord and give you a moment to look at 3 examples of what are not chords. So thinking of this, feel free to pause this video at any time. This curriculum, these activities work when you try to think of your answers first and then come back together with the video to confirm your thoughts. This is also supported by the Desmos activities that we have to go along with this lesson. So the definition of a chord is what we're asked to come up with. A chord is a segment whose endpoints are on the circle. So let's take a brief moment and look at the ones that are not chords. So in this case, this segment's outside the circle. It's not even touching my circle. This particular segment is actually a radius. It has one endpoint on the center and one endpoint on the circle, but both endpoints are not on the circle. And this particular segment has its endpoints outside of the circle. It does go through my circle, but it doesn't have its endpoints on the circle. So if we look at the first 3, all 3 of these examples have their endpoints on the circle. So something to note is a special chord. A special chord is the diameter. A diameter has its endpoints on the circle, so it's a chord, and also goes through the center. So for example, we could say that this is a chord, but more specifically, it's even more special than just a chord. It's a diameter. Continuing with page 154, the next page, we're going to look at arcs. So in this particular example, it shows me 3 arcs and 2 figures that do not contain an arc. So take a moment and look at those. So now we're going to write our definition of an arc. An arc is the portion of a circle between 2 endpoints. So looking at the first 3, if you notice, this is some portion of the circle that's highlighted in between 2 endpoints. Here, this is a parabola. It's a portion of a parabola that is highlighted. And here, this is a chord. We just learned it on the previous page, but it is not part of the circle, the curve of the circle. So we have 3 arcs in this case. Generally, we name arcs with their endpoints. So if I could put an A here and a B here and an O here, We could call this circle O. We name a circle with its center. And on this circle, there's an arc. The arc is arc AB. And we write the AB together and we put an arc curve above it. And if you saw this, you would say arc AB. And you would know that we were talking about this blue, navy blue, highlighted portion of the circle. Let's continue on to page 154 with our definitions. On this page, we're going to learn about a central angle. There are different types of angles we're going to learn in a circle, and the central angle is our first one. So the first three pictures show an example of a central angle. It's this highlighted angle that you see in the pictures. In this picture, it's showing you three angles that are not central angles. So take a moment and look at the difference, and let's see if we can come up with a definition of a central angle. A central angle is an angle with its vertex on the circle's center and endpoints on the circle. So the vertex is on the circle's center. So let's go back and look at this. This angle's vertex, the point in the middle, was the center of the circle. This angle's vertex, the point in the middle, was also the circle's center. And finally, this looks like a diameter, but it happens to be an angle that's 180 degrees because it's a diameter. This is 180 degrees if it was my diameter. So this is also an angle. It's a straight angle, but the vertex is the center of my circle. This particular angle's vertex is not on the center. It's on the circle. We're going to learn in the next lesson that this is actually called an inscribed angle. So this angle is coming up for us to look at. This angle is neither a central angle nor an inscribed angle. It's not special in any way in the sense that its vertex is just inside this circle. And finally, this is going to be called a circumscribed angle. We're going to learn about those in another lesson. This angle is outside my circle, and its endpoints are on my circle. So these are both angles we'll learn, but they're not central angles. My central angles have its center on, has its vertex on the center. So let's look at a few examples of the central angle and why it's useful in our study of circles. So please note an arc. So an arc's measure is equal to its central angle. So let's look at two examples of this. So example 1, let's draw a circle and we'll call it circle B. And on circle B, put a point A towards the top and a point C towards the right side. And go ahead and connect those, creating a central angle at B. So this angle ABC, let's say that this is 74 degrees. So then I know the measure of angle ABC equals 47 degrees. But I also know, because it's the central angle for arc AC, I also know that arc AC is 74 degrees. So we could say the measure of arc AC, we write AC with an arc symbol. Oh, sorry, did I say 47? That's a 74. That's funny. We say that arc AC is also equal to 74 degrees. So let's take another example. So example 2, let's draw another circle. Circle 0, circle O. Sorry, we label with letters, not numbers. And let's draw an obtuse angle. So we'll put D somewhere over here, and we'll put E somewhere over here, and we'll create angle DOE. And we'll say that this is 120 degrees. So then I know the measure of angle DOE equals 120 degrees. I also then know the measure of my arc. The arc formed by this angle goes from D over to E. So I know the measure of arc DE is also equal to 120 degrees. So on the next page, page 156, let's take a look at this diagram. In this diagram, they're telling us that the segments, the chords, ED and BC are congruent. So then I know the measure of ED is congruent to the measure of BC. I know they're the same length. And I actually know a lot of other details. My arcs, congruent chords, have congruent arcs. So congruent chords have congruent arcs. So in this case, I also know the measure of ED, arc ED, the arc formed from E to D, the yellow one, is congruent from the arc formed from B to C, the blue one. So the length of the yellow and the length of the blue would be the same as well. My arcs are congruent. By the way, whether I write it ED or DE or BC or CB doesn't make a difference. And then there's a third thing I know to be true. Let's make our angles, our central angles. So here's my central angle, BAC, let's say. And let's draw my central angle, DAE, right here. I also know that these angles are congruent, but since my arcs are congruent and measured to my central angle, if my two arcs are congruent, my two angles are congruent. So that would mean the measure of the measure of angle BAC would be congruent to the measure of angle DAE. My two angles would be congruent as well, my two central angles. So a lot of neat relationships in that picture. And lastly, let's look at your summary on page 157. There is a diagram with 3 circles that I would like to discuss on this page. So in today's lesson, you should have learned the definition of a chord. A chord is a segment whose endpoints are on the circle. There's a special chord, a diameter, which would also go through the center of my circle. We've talked about a central angle today. My central angle in this case would be PQR, and my central angle is congruent to its arc. So if this central angle is 156 degrees, I would know that the arc between P and R is also 156 degrees. Let's take a look at this diagram. So I have a right angle, DAB. So if CAB is a diameter, that means that this is 180 degrees. This semicircle is also 180 degrees. So if this is 90 degrees and it's a central angle, DAB, then arc DB is also 90 degrees. An arc is equal to its central angle. So coming over here, if these two angles are congruent, notice they have a single arc and a single tick mark. If they're congruent, if they're equal to each other, they also must be a total of 90 degrees, because 90 and 90 would be my 180 for a straight line. So then I know this is 45, and I know this is 45. I also know my blue arc ED would be 45 degrees, and my arc EC, my pink arc EC, would be 45 degrees. I would have 90 plus 45 plus 45, 180 degrees in this semicircle. There's 180 degrees in my other half. There's 360 total degrees in a circle. So we've discussed arcs today, central angles today, and chords today. Thank you.